Good morning and welcome to yet another video. In this one, we're going to be building a scaling card carousel. I saw this one while browsing on Dribbble and I came across it when I was building the AI image generator in the previous video. So if you do enjoy building this, you can have a look at that UI and probably build out the full application and probably use this in a whole bunch of other apps. So if you're ready for it, let's get straight into it. Alrighty, so in this video, we're actually going to be taking a look at how we can build a scaling scroll stack of cards. I don't know what you want to call it, but it's a stack of cards that looks like this. I saw it when I was building the previous video, which was an image generator, and I came across this user interface that looked awesome. It has this nice little stack of cards over here. So what we're going to be doing is building this stack over there, and then if you've built the previous video, you can go ahead and put them together and use it for whatever you like. But let's jump into the code. We're going to head over to Xcode, and so I'm going to be using the same project that I had for the image generator, but you can go ahead and create a new one. So I'm going to go ahead and create a SwiftUI view. And I'm going to call this Scrolling Carousel, and we're going to be working inside of this right here. Now this is a bit of a complex UI element to build, so just bear with me as we go through this step by step. I'm going to try my best to make it as easy as possible and walk you through how we're going to build this. So the first thing we want to do is just create a card model. Super simple, but we're just going to say struct card, and inside this we're going to say let ID equal UUID. We just want each card to be unique. I'm going to say let colors equal to, and I'm going to create a range of colors. I'll still use American spelling. This will be an array of color, so I can go ahead and say red. Honestly, you can do this in any way you like, but I like to create as many as possible so that the cards don't repeat themselves. So I'm going to go in here, and the first thing we're going to start off with is, of course, a Z-stack, because we want our elements to be placed on top of each other. So we have a Z-stack, and the Z-stack is going to have a for each, and we're going to iterate through every one of the cards. Now we don't actually have the cards yet, so let's say let cards equal, and we're going to just create an array of, let's say 1, 2, 3, 4, 5, 6 cards. And so we're going to iterate through all our cards, and this is going to say card. Let's go with a V-stack, and inside that we're going to say the text is just hello. Make sure we have ID, and it's identified by its ID. Now we've got a Z-stack of all our cards, basically. Now, so we can manage the correct sizing, we're going to wrap this in a geometry reader, and the geometry reader is going to have a reader here, and pop the Z-stack inside. And up top, we're going to create a state variable, state, and private var screen width of type CG float, and we're going to start that off at 0. And we also want one that's going to be for our card height. So state private var card height, also CG float, and we're going to start that at 0 as well. Now on a pair of our Z-stack, we're going to say screen width is equal to reader.size.width, and this will grab the screen width from our geometry reader. And now what we want to do is create two variables. One of them that controls the width of the card in relation to the screen width, and also one of them that controls the height of the card in relation to its own width. And that's basically the aspect ratio. So let's say let width scale equal to 0.75, and that means that the width of our card is going to be 0.75 the width of our screen. And then we're going to say let card aspect ratio, and that's equal to 1.5. So if we go back down here, we can say card height is equal to screen width times width scale times card aspect ratio. And that'll be our card height, basically. To make sure that we can see that in action, we're going to go ahead and add a frame onto our card, and we're going to say dot frame width is going to be the card width, screen width times the width scale, and then the height is going to be card height. And to make sure we can see it, we'll say background, and so the background here is going to be card dot colors dot random element, and that's pretty much the correct size that we want, but obviously we can't see anything underneath because we haven't added any dragging. Now this is where we start to add the dragging gesture. So we're going to say dot gesture, and this one is going to have a drag gesture, and then we want to track on changed, and also we want to track on ended. Get rid of this, and also on changed. So in the on changed we have our value in, and this is where we make those modifications, and then this is also our value, and we make these modifications, re-indent everything. So all we want to do in our drag gesture is keep track of our drag offset. So we're going to have a state variable, and we're going to call that drag offset, and that's going to be of type CG float as well, and also start at 0. And so inside our onChange, we're going to say self dot drag offset is equal to value dot translation dot width. And then to be able to modify this, we now want to have an offset of our X value. So our X offset is going to be card offset for index. And now by doing this, we've realized that we actually need to keep track of the index. So one way to do this is to say indices, and we can say self, and this will be index, cards, index, and that's pretty much what we got. And now we need to create a function called card offset for index, and that's an integer. Make sure that this returns CG float. And for now, we're just going to return 0. Now, one thing we want to keep in mind is that as we're dragging our cards, we will always have what we call an active index. The active index is going to be the card that is pretty much appears to be on top, but isn't really. So as we're swiping across and dragging our cards off the screen, the card that's now in view will be considered our active index. So what we need to do is calculate what our active index is, and then be able to then use that to calculate what the next target index is for every single other element. So the element after its target index will be the index before it, and so on and so forth. And we use that so that way we can determine how far we're going to drag the offset, our scale, and our opacity as we're dragging the cards. It sounds a bit complicated, but we're going to work through this step by step. So let's get into it. The first thing we want to do is calculate what our active or adjusted index is. I'm going to leave the return here so that we don't have any errors as we're doing it. So we're going to start off by saying let adjusted index equal to our index minus active card index. And for that, we need to go up here and make sure we declare an active card index. And that's going to be equal to 0. So at first, our active card is going to be 0. And the time that we're going to change that is actually on our onEnded function. So we're going to go in the drag onEnded. So once the drag ends, we still want to determine a sort of threshold for the drag. So let's say let threshold equal to screen width times 0.2. So if you swipe basically 0.2 of the screen width, that's the threshold, and the card should fly off the screen. At this point, we then say with animation, because we want to make sure that it looks clean and smooth, if the value.translation.width is less than minus threshold, so that means if we're dragging to the left, then we're going to say our new active index is equal to the minimum of our current active index plus 1, and our cards.count minus 1. The reason we use the minimum is if we swipe all the way till the end, we're always going to take the last value. So if I go and say active index, which is now the last index, plus 1, that's going to be more than the number of cards I have in the first place, or the index of the last card. So we never want to drag more than the last card, and that's why we use the minimum here. So then we're going to say else if, and this is now if we're dragging to the right, we want to bring the cards back. We say value.translation.width is greater than threshold. So if we drag more than 0.2 of the screen width to the right now, we're going to say our active card index is equal to the maximum of our active card index minus 1 and 0. And that's also because the lowest card that we can ever have is going to be 0. You can't get anything less than that because then we're in negative indexes and our index will be out of range. Now let's go and jump back to our card offset. And so our adjusted index is equal to our index minus the active card index. Now, before we start dragging the card, we need to keep track of the initial offset. Initial offset at this point is going to be CG float and convert our adjusted index. We want a card spacing, let card spacing, and for now it's going to be 0. Let's just say that there's no spacing between the cards, and it's going to be a card spacing times the adjusted index. And that's how we determine how far each card starts off. So the first card will be 0 times that, so the initial spacing will be 0. The next one will be our card spacing times 1, so some slight distance. So let's just start off with a number like 60. And make sure that this is CG float. I also just realized that my leg is numb, but not a problem. We shall continue. We have our initial offset, and now we're going to say, so this is how we determine what is happening to each card, because the animation we see will be determined by whereabouts the card is in the stack. So if the card is on top, we're going to just drag that card to the side. Nothing really changes in terms of its scale, only its offset. It just drags off the screen. If the card is after the active index, that card is now going to start to scale up and move. Well, obviously we're dealing with the offset right now, but it's going to scale up. Its opacity will start to increase or decrease opacity. Yeah, so yeah. And then we end up having that card now visible, also full size and in the place of the card before it. The other part is if the card is now less than the active index. If we're dragging off, nothing really changes, but if we're dragging back, then that card is going to slowly come back. A lot of different cases, but we're going to work through those slowly. So if active index or adjusted card index is less than 0, so that's if the card is already off screen, we're going to say if the drag offset is greater than 0 and the index is equal to active card index minus 1. And that's because we only want this to happen to the card just before. So we're checking if if we're dragging to the right, so we're bringing the cards back, and the index is the card that should be coming back, which is the active index minus 1. Then we're going to say let progress, so the progress of the drag, equal to the minimum of the absolute value of our drag offset. So because our drag offset, we already know that it's moving straight, so we want it to be a positive. So that divided by screen width on 2 and 1. Now why screen width on 2? That's because I want the card to basically come all the way back, so it should be in its full position after you've dragged half the width of the screen, or the same thing when we go off. So you'll notice we're using screen width on 2 a lot. So we're going to say that that's the progress, and then the distance to move is going to be equal to our initial offset plus screen width times the progress. Now for this one, it's the screen width because you'll see that later we throw it off the screen. So we're moving the screen width plus the initial offset times the progress. And we're going to return minus screen width because that's where it was before, plus distance to move. The next case we're going to say is else if we're not dragging anywhere other than that. So if we're dragging to the left, or if it's not the right index, we're just going to always return minus screen width. So we're going to have a screen width off the screen. We're not really interested in where that card is at this point. Now, our next case is if our index is greater than the active index, or active index, correct. So else if our index is greater than the active card index, so that's all the cards after the main card. We'll leave the main card till the end. Now what we want to do in this case is say let progress is equal to, once again, minimum of the absolute value of, since we're going to say that let progress equal to, let's just grab the progress here, pop it there since we're going to be using the progress the same in all cases. We don't need to keep defining our progress. So we're going to say let distance to move equal to progress multiplied by the maximum that the card can move. So we need to identify what the maximum card movement is, and that is let max card movement equal to, at this point let's just say it's equal to card spacing. So maximum card movement. So the maximum that the card can move, we're going to multiply that by the progress, and then we're going to say return the initial offset, so where the card started off at, minus, now if the drag offset is less than 0, so if we're dragging to the left, we're going to return distance to move. Otherwise, we're going to return minus distance to move. And that just means we're dragging either to the right or to the left. Now dragging looks really funny here, so let's leave that alone. And the final case is else, and in this circumstance, this is our main card. If our drag offset is less than 0, we're going to constantly return our drag offset. So we're going to return drag offset. But if we're dragging to the left, we're dragging off the screen, we want to follow that drag offset. And then we're going to say, if we're dragging to the right, we're going to say let distance to move equal to the max card movement times progress. And then we return the initial offset minus, and once again, we're going to grab from up here. Basically use the same function there. I got rid of distance to move. There we go. And then in this case, we're going to remove the return 0 because we don't need that anymore. Now we're getting close. We can now see that the elements are somewhat arranged in a manner that seems okay. The only problem is, from what I can see here, let's have a look. If we go over to this and we just add a shadow, let's say 12, you'll see that the cards are actually stacked in the wrong direction. So we want the cards to be the other way around. And the way to fix that is by adding a z index. So we can add that on here, z index, and that's just minus convert to a double, the index. And there we go. Now the cards are stacked in the correct direction. Now, the only problem we have is as we're dragging this, you can see that weird effect. And that's because every time we render, we end up changing the card because we're using random element. So I'm just going to say the colors, I'm going to say index percent card count. And that should always give me the same color. There we go. So if I go like this, we're kind of getting somewhere. We're sort of close. You can see as we drag, our cards sort of go off the screen, and we can sort of bring them back. One thing we want to do is make sure that once our drag is actually finished, that we reset our drag offset. So we're going to say drag offset is equal to 0. So that should fix one part of it. So if we just drag this off, there we go. So our drag offset is 0. So we kind of have the effect that we want. Now we want to basically place these cards somewhat in the center. And to do that, we're going to offset the entire view. So from here, we're going to offset the entire view. Really now you can just have some form of offset. So you can just say, I want it to be 30 from the left. I might go with like 16, say like a standard padding, and then dragging the cards are always like 16 off the screen. And I just want to see the cards from the top. So I'm going to add a Y offset of about 30. There we go. So now we can actually see the cards down here. And to make them look a little prettier, let's go ahead and add a corner radius. So let's go to our background and add a corner radius of 20. And now we have some nice cute little cards. So this is our offset. We've basically worked through our offset, and you can see as we drag it back, even when we drag this card, they still all move. Now the last thing that we want to do is take a look at our opacity and then also our scale. So we've kind of done what I would say is the hardest part of this. So we're going to say a function card scale, and this is going to also take for index integer, and this is going to return a CG float. So return 0 again in this case, and let's go up to where we have our offset, and under our offset we're going to say scale effect, and we want to make sure that because it's a CG size, we're going to say our X scale is card scale for index, and our Y is also card scale for index. And now our scale actually for this, so we can see something, we're going to return 1, not 0, or 1.5 makes it big, 1.2, 3, 2, 1, there we go, card scale. Anyway, so let's go into our card scale function and start writing the code. This is a lot smaller than the card offset. There's a lot less to handle in this case because most of the time you're just scaling up or down. So what we're going to do is also add in a variable, proportion, and CG float. And the proportion is going to be 0.2. So what proportion is what proportion do I want the card after the main one to be scaled, or the next card to be scaled down. So I want the next card to be 0.2 of the previous one, and so on and so forth. So I'm going to let this be a variable so I can modify it from up here, but I'm going to give it a default value of 0.2. Once again, we want to grab our adjusted index. So let's say let adjusted index equal to the current index minus active card index. And if our index is greater than active card index, we're going to grab the progress, similar to the progress that we had up here. So let's grab this, progress. You could probably turn this into a computed variable, but anyway, let progress equal to the minimum absolute value of the drag offset divided by the screen width on 2, just based on how far you're dragging. And then we're going to return 1 minus the proportion times, now this is where it gets a little bit juicy, CG float adjusted index, okay? Bear with me. So the proportion multiplied by the adjusted index. So if we're on the second index, it'll be slightly more than the third index, and so on and so forth, or the other way around. Yeah, sorry. The third will be scaled smaller than the previous one, fourth more than the third, fifth more than the fourth. And then we're going to add drag offset less than 0. So if we're dragging to the left, then we're going to add proportion times progress. And if it's the other way around, then we're going to say minus proportion times progress. And now you can see we cannot see a single card. And that is because we're going to go back up here and we're going to change this to say 60, 50, 100. And what you'll notice is as we continue to increase these, each of these doesn't have an equal value. And that's because our scale is changing the relative offset. And that means we need to adjust our card spacing based on the card scale. So we're going to say card scale for index. Let's pass in that index. And we're going to multiply that by, we're going to say, let's, something like 60 divided by that. There we go. That looks a little more reasonable. If we want maybe, let's say 50, no, I think 60, maybe even, yeah, 60 looks good. So now we can see 3 cards. And what's awesome is now as I'm scrolling one, you can see that they're all increasing in size. And if I bring it back, they all decrease accordingly. Now, one thing I noticed is as I'm dragging this, the second card increases. That's great. But then when I bring it back, that card only decreases once I let go. And that's because we have index is greater than. We want to say greater than or equal to. So we group it in and then it'll drag and go back into its place. Last thing I want to do is add an opacity. So I want these cards to kind of not exist unless, like slowly disappear more into the background. The way we're going to do that is we're going to add an overlay. I originally tried by adding an opacity onto each of these, and then obviously realized that by doing that, you're actually going to show the cards underneath. And so the opacity ends up adding up and it just doesn't work the way you expect it to. So what you're going to do is jump over and go to background. Where's the background? Here we are. We're going to add an overlay, and the overlay is going to be the same color as your background. So in this case, my background is white. So my overlay here is going to be color.white.opacity 1 minus card scale for index. And I want to say proportion. For this one, I want the proportion to be like a lot higher. And then also I want to remove the shadow so I can't see those. Maybe let's make it 0.4. There we go. So as I drag, you can start to see the card coming in from the back. If you do still want to add the shadow, you can add the shadow, but just make sure that you change the shadow color to work accordingly. So if I drag, you can now see each of these cards. And if I swipe back, you've got this cool animation that works super nice, super clean. And honestly, as complicated as the maths is behind this, I hope it's self-explanatory, or I hope I managed to explain it really well. We've got the code for this. Now, if you want to implement a structure like this, something similar, go ahead. You can build something similar to this card swipe. I've seen another one that's like stacked vertically. And so if you like drag it down, they pop up in your face. It works pretty much the same as this, but instead you just modify it to be a horizontal offset rather than a vertical rather than a horizontal offset. So I hope you enjoyed this video. Let me know what you guys build with this. Feel free to share it to me and ask any questions in the comment section below. Don't forget to leave a like. Apparently that makes a difference to the algorithm and helps with the video. And I will catch you in the next video. Peace.